Alrighty, today we're going to be having a look at determining the equation from 3 points. This is going to be quite tricky, and the only way you can do this, if you do not know the turning point, you do not know any roots, this is the only method that's left to us. And we're going to have to use the general form of the quadratic. Theoretically, you could use any form, but this form is going to allow for the most simple when we're going to be trying to use these different techniques that we're going to be looking at. And in particular, we're going to be doing a more complicated version of the simultaneous equations that we looked at last time. So before we get into it, let's just quickly plot down these points just so we can kind of get an idea of what this graph is going to look like. So we've got 2, -3, that's this point down here. We've got -1, 9, so it's going to be a point up here. 5, 6, 7, 8, 9. Look at that, perfect. And we've got 1, -1. And so we're not really sure exactly what it's going to look like. It could be something looking like this. It theoretically, it's probably not going to be concave down. It's probably going to have to be concave up of some sorts. We don't know how low it's going to go. But these are the 3 points we've been given. So we're just going to have to do our best to try and work out exactly what the function that fits these is. So step 1, let's just sub in each pair of points into the general equation. So sub in, let's try 1, -1. Let's do our first point. So we get -1 is equal to a times 1 squared plus b times 1 plus c. We get -1 is equal to a times 1 squared is just a, plus b times 1 is just b, plus c. This is equation 1. Let's do it again, but this time let's do it for the next point, -1, 9. So we get 9 on the left-hand side, a times -1 squared, plus b times -1 plus c, which gives us -1 squared is just 1, so a, b times -1 is minus b plus c. There's equation 2. And lucky last, let's sub in 2, 3. And these are going to make up our -3, sorry, not +3, -3. And these are going to make up our 3 equations. 3 is equal to a times 2 squared plus b times 2 plus c. -3 is equal to 4a plus 2b plus c. And this is equation number 3. Alrighty. So stage 1 is to try to eliminate one variable. Now the easiest variable to eliminate in all of these is to eliminate c. Why? Because similar to the previous one we looked at, if you subtract any of these from each other, c is going to go, because it's going to be c minus c, c minus c, c minus c. It doesn't matter. No matter what, it's going to get rid of c. So let's do that. Let's get rid of c. So remove a variable. Alrighty, I'm going to start with equation 3, because equation 3 has the highest coefficients. I don't care that it's got a negative on the left-hand side. I'd rather keep the letters in front of a positive than I'd rather keep the other ones. So let's go 3 minus 1. Alrighty, so I'm going to copy out 3 and 1. Alrighty. So 3 minus 1, that's equation 3, that's equation 1. So -3 minus -1 is minus 2. 4a minus 1a is 3a. 2b minus 1b is b. C minus c is no more c's. Goodbye c. Alrighty, let's do the same thing. Let's call this new equation equation 4. Alrighty, let's try it again, and this time let's go 3 minus 2. So once again, I'm just going to copy out 3 and 2. Alrighty, and in this case, we're going to go -3 minus 9 is -12. 4 minus a is 3a. 2b minus b is plus 3b, c minus c is gone. So we are now left with two equations with two variables. Notice we started with 3 equations and 3 variables, and now I've worked it down to 2 equations and 2 variables. Well, I actually already know how to solve for 2 equations and 2 variables because that's just the simultaneous equations we've done before. So let's look at these 2 equations, 4 and 5, and go, well, how can I eliminate? Well, this one's bigger than this one. They both have this 3 in front of A. So let's eliminate them. So let's go 5 minus 4. So we're going to do another elimination step. See what we get. Alrighty, so there is equation 5 minus equation 4. 12 minus 2, well, that's 12 plus 2, which is negative 10. 3a minus 3a is no more a. 3b minus b is 2b. And so I now know what b is. Hip, hip, hooray, it's negative 10 on 2 or negative 5. Okay, I've now found one variable. But remember, just like before, I need to find all 3. I can't just find x, I need to find x and y. In this case, I can't just find b, I need to find a, b, and c. So I know what b is. Next game, figure out what a is. Well, I can do that nice and easy as well. I can just substitute into my favorite equation between these two. It doesn't matter which equation I sub it into. Either way, it's going to work fine. So let's sub b equals negative 5 into, I think I prefer the look of 4, so I'm going to sub into equation 4. So I get minus 2 is equal to 3a plus negative 5. Add 5 to both sides. And I'm left with 3 is equal to 3a, therefore a is equal to 1. I now know b and a. What do I need to figure out? C. So now I need to go back to one of the original 3 equations I had, choose my favorite, and substitute in a and b and solve for c. So I'm going to choose equation number 1, because it looks pretty easy. Negative 1 equals a plus b plus c. So let's sub in b equals negative 5, a equals 1 into equation number 1. Negative 1 is equal to a plus b plus c. A is 1, b is minus 5. 1 plus minus 5 is negative 4 plus c. Add 4 to both sides, and we are left with 3 is equal to c. And therefore, we now know a, b, and c, so the equation is y is equal to ax squared plus bx plus c, except we know a, b, and c. A is 1, so that's just x squared. B is negative 5, so that's minus 5x. And c was 3. And there is my equation. You can double check it by putting it into a graphing thing and checking. The other way you can check is just by subbing in points. I know that when I sub in x equals 1, I know what I should get on the other side. When I substitute x equals 1, what should I get? I should get negative 1. So this is how, if given 3 points, you can solve using advanced simultaneous equations to solve for the equation of a quadratic. It takes a little bit of practice, but it does get a little bit easier over time. Alright, I'll see you in the next one. Goodbye.